Hi, everybody. Welcome to today's session on acing technical maths on the calculator. I'm very excited to have you join us today, and hopefully we can have a lot of fun while we do this. So I am going to share two different screens with you, so we'll switch between the two. But if you get stuck or you miss something, please feel free to pop your questions into the chat function or the Q&A, and I'll try and answer them between switching topics. I think that's the best way to do it. All right, so I am going to share my screen with you. Here we go. All right. When I was chatting to Cynthia about what to present to everybody, there was the fact that a lot of people were struggling with certain topics. So I've included them in here, but I've tried to include everything that is in the technical maths syllabus. So we'll see how far we get and go from there. So this is the plan for today. I know it does say 2.5 hours. I think we'll be finished before then. So let's give it a go. So before I continue, Sharpies is a maths teacher reward program. So if you're joining us, hopefully you're a maths teacher, and you will join the Sharpies program. So basically you get points for doing fun stuff like telling other people about Sharpies or purchasing calculators from us or changing your stationery list and so on. And then what you can do is spend those points online. You can buy Bluetooth speakers or laptop bags or other cool stuff as well. And then, of course, this is a list of some of my favorite things. So if you want to download the simulator that we're going to use today, you can use this link here. And then, of course, I'll show you a little bit of GeoGebra, which is epic and such a great way to teach functions and trigonometry. So I'll show you, you can download it from here as well. It's also a free resource. So everything I've included here so far is a free resource. Then, of course, Maths at Sharp does have some technical maths worksheets. And eClassroom is not super friendly for you, but Math Drills and mathx.com are fantastic worksheets for older grades. And then, of course, if you need the ATP documents, they are through this link. And I have started my own personal maths blog, which should be available from around the 1st of July if you're looking for extra resources. All right. So today we're going to be using the Sharp W506T, and every teacher that joins this session will be receiving their very own W506T. I will get your registration details from Cynthia afterwards, so don't panic. So you'll all be receiving one of these. It's an absolutely stunning calculator for technical maths. It's got complex numbers. It's got highest common factor, lowest common multiple, unit conversions, which are really awesome, and I'll show you how to do that using the calculator. So just some quick admin-y things. Obviously, to turn the calculator on, you need to use this button. To switch it or to use any orange functions, you're going to use the second function button. Your mode button, we'll discuss modes in a second. BS is for backspace, not what your kids write in a test. And then, of course, change, which will change the way that your answer looks. And we'll use that when we talk about recurring decimals just now. And then, of course, equals button, which will help you find the solution to world peace. No, I'm just kidding. But it will help you find the answer to whatever question you've typed in. Okay, so this calculator actually has 9 different modes. So we're going to use normal, we won't do any stats today. We'll use the table mode, the complex mode, and the equation solving mode as well. And then, of course, drill, which we won't talk about today, but let me just mention it now, is a fantastic practice for your students. So what it does is it asks basic mental maths questions, and then the students have to answer the questions. If they get it right, they get a tick. If they get it wrong, it marks it wrong and repeats the question again. And it's very patient. It's going to keep asking until they get it right. Okay, and then at the end, of course, you will see a mark and a percentage as well. So the first thing that I want to show you is a teacher shortcut for class marks. And I'm actually going to do this on I'm switching here. This is a new platform for me, so forgive me. Awesome. Okay, so I'm going to share my calculator, which is now, there we go. Here it is. So here's the calculator. We're going to do a shortcut for class marks. So what I'm going to do is press the fraction button. And then at the top of your fraction, you put whatever you want to convert your class marks to. So if your test is out of, or sorry, you want to convert all of your marks to something out of 100. So you're looking for the percentages. You're just going to type in 100. At the bottom of your fraction, so you just use your down arrow key to move down to the denominator. You're going to put in whatever your total for your test was. So let's say you set a test which is out of 80. Okay, so we're going to type in 80 here. Then we press our right arrow key to get out of the fraction, and we say times. And what we do is we type in our first student's mark. So the first student got 55 out of 80, right? Then we say equals, and we get 68 3/4. And then, of course, we use our change button. So change will just change the way it looks. So what it's telling us is that this student got 68.75%. Now, for your next student, all you're going to do is type in the next mark. So if the next student got 63 out of 80, you're just going to type in 63, and you're going to press equals. And then you'll see it will give you the ratio, which is 100 over 80 times 63, and that is 78.75%. Okay, so, and then you can just keep doing it. So the next student got 35, so we say 35 equals, and that's, wow, I really have a great option for picking 0.75s. So the student got 43.75 or 44%. The next student got 20, and so on and so forth. Okay, so that, I'm going to go back to my other demonstration. So these, this is make it available for you to download off Maths at Sharp. I will send out a link to everyone who attended the presentation afterwards once I get your contact details, so that you can follow along once you receive your calculator as well. So I basically followed the set topics in the CAPS curriculum, and I'm just doing all of the things that I think we often tend to struggle with. We don't know what to do on the calculator. So to my calculator now, and it's hiding away again. My goodness. Okay. So we can say we have a half, and we want to add 2/7 to that, right? So we're going to say, let me just start again. So what I'm going to do is you can put in a fraction in two ways. You can either press the fraction button first, like we did with the class marks, and then put in your numerator, press down, and put in your denominator. Then press your right arrow key to get out of your fraction. Or we can do it the quick way, in which we type in the numerator first, then press the fraction button, and then just type in the denominator. So it's up to you, whatever makes you happy and more comfortable. And then, of course, we just say equals, and we get 11 out of 14, or 11/14. Now you can see I've actually got a recurring decimal set up here. So what this 9 is telling me is that these numbers are repeating over and over again according to this pattern. And if I change it, you can see there's the repetition for you as well. So you can just loop through those things. Now we have to actually turn the calculator on in order to do this. So to do that, we're going to say second function and setup. And then we are going to press down, and we're going to choose 5 for recurring decimal. So before I do that, number 6 says decimal point. And that is basically whether you want to choose a dot or a comma on your calculator. Up to you. I like the decimal points. It's not as confusing. And then 7 allows you to type in your name, so that when you switch off your calculator, your name comes up underneath the brand of Sharp on your calculator, which is really cool and fun. And you can play around with that when you get the calculator as well. So we're going to press 5 for recurring decimal, and we're going to choose 1 for on. And now when I say change, you obviously it's still on, so it will still recur for you. Okay, so it's very strange to see my face popping up all the time. Right, so here is that decimals as well. Now, the next thing that I want to show you, which is really awesome, is the so I'm going to go back to my calculator screen. There we go. Okay. Is new to the technical maths topic is the binary. Okay, and yes, the 535, which is our junior calculator, also does binary. So just a heads up on that one. So let's say, for example, we have the number 257 and we want to convert it into a binary number. So what we do is we just say, type in the 257. We can say second function, and we're going to choose divide. You can see in orange it says binary. So we're just going to press the divide. And now we have the binary number of 257. I picked a really great example. Then, of course, you can add these binary numbers together. So you can type in whatever other binary number you have. Just remember that any other number that you try and type in is not going to work because you are in binary mode. And then, of course, just press equals, and there's your answer. Now, if we wanted to convert this binary number back into decimal format, then all we would do is say second function and equals. You'll see there it says decimal, and we get an answer of 441. Okay. So that's binary numbers, which is really, really awesome. And complex numbers. Just give me a sec. It's very windy where we are and everything is blowing open. So I'm not gonna work through these slides. I'm actually just going to do it on the calculator for you. So to do is bring up my calculator, and I'm going to share. We're going to go and do some complex numbers. Now, I know this is complex numbers are really actually quite great. So we're going to say mode, and we're going to choose 3 for complex numbers. There we go. Now, in your left-hand corner of your calculator, you can see the XY screen. So we are working with rectangular coordinates. If you want to change the format of that, in other words, work with polar coordinates, then all you would need to do is say second function and h. You can see in orange it says 2r theta, so that means 2 polar coordinates. Now, when you type in, let's go back to our rectangular coordinates. So when you type in something and you want to say 3 plus I, so we can say 3 plus, and then our DMS button is our I only in complex mode. Okay, and we can say equals, and you'll see it will break it down into real numbers and imaginary numbers. Then, of course, you have a couple of maths options. So we're going to press the math button, and you can see you've got the conjugate, you've got real, and you've got imaginary. So if I wanted the conjugate version of an complex number, which I mean is pretty simple and not necessarily something that would need to be typed into the calculator, but hey, we can do it anyway. There's your conjugate version of your number. What's really great here as well is you can convert from these rectangular coordinates into our polar format. So that is your your arc and your angle theta. There it is there. So that's really handy. And of course, you can do this again backwards. So we can say 15. Your angle is here. So we're going to say second function and x, y. And that gives us our angle format of, say, 60 and equals. And then converts it back into our rectangular format as well. So that's pretty much everything that there is to do with complex numbers. So what I'm going to do, share. Try to get clever there. I'm going to go back to functions now. There are several functions, and what's really nice about the technical maths is that you don't get any of these P things, which I think is the most confusing thing when it comes to teaching functions, which is really great. So I've just listed a whole bunch of important terms here on the for functions, which you're welcome to share and use. And then, of course, talking about your axis of symmetry and your turning point. So with your parabola, in grade 10, which I never realized before, but which is really nice in technical maths, is you only actually ever deal with x squared plus q, whether it's positive or negative. So in other words, whether the graph is upside down, happy or sad. Okay. And then in grade 11 and 12, you become more advanced with that. So what I wanted to do was actually investigate the effect of A, which is appropriate for grade 11 and 12. So what I'm going to do is I'm going to switch back to my calculator screen. And we're going to talk through the table mode. I'm going to just do the presentation because it's easy enough to follow. All the steps are there. So what you would do is press mode and go to table. Okay, and the first thing that we're going to type into table mode for function 1 is just x squared, right? So just press this button twice, RCL makes an x. If you prefer the other method, alpha and then RCL. Same. Okay, then we're going to just press the x squared button, and we're just going to jump through and go through to the table. So just press equals until you reach the table. And here you can see all of your coordinate pairs for x and y. And if I go back up, there they are there. What's really, really nice about the Sharp calculator is that your table is unlimited. So you can go for as long as you like, and you're not going to run out of space ever. Now, while plotting functions, this is, I mean, you're obviously going to have a set width of what you're plotting. But for things like doing simple and compound interest, which I'll show you just now, it's really awesome. Okay, so what you would do is actually plot just this graph. Okay, then what I'm going to do is I'm going to leave function 1 as x squared. And in function 2, I'm going to multiply x squared by 2. Okay, so we're just investigating the effect of A. And then, of course, say equals, equals, equals. And here you can see what's happening is where this column is 4, this one has been doubled to 8. So everything has been multiplied by 2, which is what we were doing. Okay, and what we would do is then draw this graph onto the same graph as the original graph. Then what we can do is leave the original graph. And in our second graph, we're now going to make our A a half, okay? And press RCL and x squared and equals, equals, equals. And there we go. Now we can see that each of these values has been halved or divided by 2. So, okay, so they're all smaller. Okay, now I'm going to go back and my presentation. Here you go. Okay, so these are the steps. Okay, and here's my plot. So this is the original graph, the one where function 1 is 1. And this is my function where it's 2x squared. And you can see that this graph is thinner than the original graph. Then what happens if I make a half, which is what we looked at next, and we can see here's my original graph in blue. By the way, guys, this is drawn in GeoGebra. And here is my new graph where A is equal to half, and you can see it makes it fatter. So what's really nice, is they can see that the bigger your A value is, the thinner your graph is, whereas the smaller, or in other words, between 0 and 1, your A value is, the wider your graph is going to get. Okay, and we can do the same thing where we shift the graph up and down, right? So here you can see, here's my original just x squared graph, and then I've added 2. And you can see for every graph or every point, it's just been shifted up by 2. I'm not going to try and attempt to draw the graphs for you because I'm very bad at that. But it is really a nice exercise to do with your students in class. So here is a summary of everything to do with parabolas and, of course, their intercepts. Then we can run the same sort of investigation for a hyperbola. So again, you type your hyperbola function into your table mode function, and then you can see here's your original hyperbola, and this is the shifted hyperbola here as well. Oh, but I do need to show you something. So I'm going to switch back to my calculator for just a sec. I know it's very confusing. Please love me still. There we go. Okay. So with the is the fact that if we draw a hyperbola, let's just call it 4 over x, right? Just a basic one. And we say equals. Let's delete that function. Equals. Do you see at 0, where x is 0, your asymptote actually looks like an asymptote on your calculator? Okay, so when they see that stripy line, they know on the pictures, on their graphs, they need to draw a stripy line as well. And again, this is really nice for exploring your values. So you can see that it just grows and grows and grows. But what I do want to come back to is the fact that you can't really see how close the graph is getting to your y asymptote. So we can change our step to 0.1, right? And what you're going to see here now is this massive growth. So you can see how quickly it falls down. I'm drawing this, but you can't actually see how fast it falls down towards your asymptotes. And if you look on this side, how fast it goes up and then starts to curve around to 2 and so on. Okay, so really this is a very nice part of that unlimited function, because you can make your steps as small as you like and really get into examining your graph in this way as well. Cool. Are there any questions in the Q&A? No, not yet. All right, fantastic. Okay, so let's go back here. So that's the hyperbola and axes of symmetry. Just a note. So with technical maths, your axis of symmetry will only be y is equal to q. Okay, because you don't have a p affecting your asymptotes. So your only asymptote is your y asymptote, and your x is equal to 0 asymptote. So your equation for axis of symmetry is y is equal to q minus 1. Okay, great. And then again, your exponential graph, none of this crazy p stuff, which is really wonderful. So, and then just some notes here. Remember, for b between 0 and 1, in other words, your base of your exponent, your base can never be negative, firstly, ever, ever, never. So just a heads up on that one. And what's really nice is if you drew that on either GeoGebra or you looked at it on the calculator, they could actually see the jumping between the points, because when your exponent is positive, then this is a positive number. And then when your exponent is negative, it will be a negative value. So that's quite an interesting exercise, just to show them why we don't have a negative b. Okay. Then again, all of your summaries, which you can download from here. Any questions before I move on? Any questions? We all good here? Right, awesome, fantastic. I do want to show you finance because it is awesome. Okay, so what I'm going to do is and work on it from there. You'd think I'd be better at this, but apparently I'm not. So, what is happening now? Sorry, guys. I'm not sure why it's being funny. All right, there we go. So, simple interest. And I'm just going to go through this with you because it's fantastic. We're still in table mode, right? So we're going to say 1,000, open brackets, 1 plus, and let's make our interest rate 5%, right? So it's 5 over 100, okay? And then when it's simple interest, what we're doing is we're multiplying by our number of years. Now, there we go. Okay, so they have to know the formula, so this is great. So we'll just start with this one. Ignore function 2 for now. Oh, let's make our step 1. All right. So your initial investment is 1,000 Rand. After 1 year, you get another 50 Rand. So you've earned 50 Rand over that 1 year, so your total is now 1,050 Rand. After 2 years, you've earned another 50 Rand, so your total is now 1,100 Rand. and so on and so forth. So you can see we are just adding 50 Rand every single time. And what we can do now is ask our students, okay, when does my money double? So I'm just going to go look for the place where it reaches 2,000 Rand. So my money doubles after 20 years. So that's simple interest. I'm going to leave that here. And what I'm going to do is in function 2, I'm going to put in compound interest. So I'm going to use the same values. So we have a direct comparison. And I'm just going to change my formula to match, right? Oopsie, sorry guys. There we go. See, that BS button comes in handy. So once you're done with that one, close your brackets, and then we're going to put it to the power of x instead. So x is just our number of years, and equals, and equals, and equals. So here's our initial investment. After 1 year, they've earned exactly the same amount. But after 2 years, in your compound interest column, you can actually see that you've earned an extra R2.50 compared to the simple interest column. And after 3 years, you've earned an extra R7.60, if we round it off, 63 cents. And after 4 years, it's an extra R15.51, and so on and so forth. And you can see that the longer you leave your compound interest in, the more you are earning per year compared to the simple interest. Okay, so if we continue on, we can say, okay, so when does my compound interest double? Well, it doubles after 15 years, whereas it took us 20 years to double our simple interest. What's also a really other great question is to ask, when is my compound interest double my simple interest amount? So all we would do is go and look for where this one is twice the value of that one. So let's just scroll through. I'm doing quick maths in my head. No, that's too little still. Is that right? 5,000. Yeah, so here it is. So after 35 years, I've doubled the amount of money than I would have had in my simple interest account, for lack of a better explanation. So from here, sorry, I don't want to switch back to the presentation. It's driving me nuttos. So from here, what's really great is you can start talking about compounding intervals. Okay, so in this one, I'm going to do a compounding interval of 1. Okay, so in other words, I only get compounded interest once a year. Okay, so just like we had in the previous one. And then for my second function, I'm going to have a compounding interval of 12. So it's compounded monthly. Okay, so here, sorry guys, you know what I'm going to do? Let me just do it. So 1,000, open brackets, 1 plus 5 over 100. And then we're going to multiply by 12. Okay. To the power of x. Okay, so you'll note that I haven't multiplied by 12, and the reason I've done that is because I want to use my x as a number of months, just for this explanation, okay, which is why I went back and changed it. So here you can see after 1 month, I've earned R4.16. After 2 months, I've earned R8.35. After 3 months, and so on. So after 12 months, which is 1 year, I've earned R1,051.16 approximately. So that's a whole R1.16 more than I did with my just compounded annually amount. Now we can go back and change this. So what I can do here is multiply this by 12, and now it gives me number of years, right? So here, if I just did my regular one, 5 over 100, compounded annually. Okay, now we can compare. Do you see? So we've earned that much extra, comparatively speaking, year on year. So you can see that compounding monthly is better than compounding annually. And we could change that. So what we could do is do it every 52 weeks. So we could do it per week. I'm just editing my equation here, which is quite easy to do, and equals, and leave this one as is, and you can compare. So for this one, this is compounded weekly per year, and this one is compounded annually. And you can see again the difference in compounding intervals. Now we can also do it with 365 days if we wanted to. like so, and equals, and comparison 1. And there you go. So now we can see even more so what is compounding. So it's just a really interesting exercise for your students, especially when we're talking about compounding intervals, because it feels so it's untangible. But with a calculator, you can really show them the difference between what you're earning. And this will only really start to pay off magically later on in life. So the longer you leave it in, the better, which is why we start saving for retirement really early, right? Because it gives us the magic of compound interest. Okay, great. So I am going to switch back to my presentation here. Just give me a minute to figure myself out here. All right, great, fantastic. So that's all of these steps here with decay. So I'm not going to do it on the calculator because you sort of know where I'm going and what I'm doing, but you can see how everything is decaying according to these steps here. Okay, and then of course, sorry, so here you can compare between compound and simple interest decay. So where simple interest, you're just losing 50 Rand a year. With compound interest, you're going to start losing 47 Rand. So it will do a sort of exponential graph decay as well. And then, of course, here is where we talked about the compounding intervals as well. So I went into a bit more depth with it with you on the calculator now as well. Now, nominal and effective interest rate. So the effective interest rate is actually the interest rate that you earned. So when we're talking about compound interest rates, that is not the same as, so when we talked about the 5% compounded daily, right, that is not our effective interest rate. That would be our nominal interest rate. So we want to find out what we'd actually earn in interest per year. And that is where this formula comes from. Okay. So I forgot that I put this in. I'm going to leave the examples for now. And oh, here we go. We can do it step by step here. So here are all the steps, right? So your effective interest rate is 12%. Okay, so I've just put it into a decimal format and it's compounded weekly. So we can see that our effective interest rate is 12.73%. Okay. Now, one of the things Cynthia mentioned that the students really struggled with in the final matric exam was timelines. And I mean, that's universal to maths. Everyone is just, so much fun with timelines. So I actually set up an example question here for you. And I just want to talk through it. It's not allowing me to draw my picture. Oh dear. Okay, I'll just do my picture. What is going on here? Sorry. Oh, there we go. Okay. Right. Okay. So forgive my handwriting. I'm not, after a year of doing this, I still am not great at it. So what you'd do is you'd put your timeline down. Okay. And then we just read the question and we're just filling in the information as we go along. Okay. So Sifiso invests 5,400 Rand in an account. Okay. So that's his initial amount. So we're going to say 5,400 Rand. And it pays 14% compounded semi-annually, which means divided by 2 for 2.5 years. So our N is 2.5 times 2. Right. That's that one. Then he withdraws 3,000 Rand. So we're going to withdraw the 3,000 Rand over here. That's our break in the timeline. Okay. And then he invests the rest of the money into an account paying 7% per annum, compounded daily, so divided by 365. And then, of course, my N is for 3 years times 365. Okay. Then he changes his investment. So again, there's another break. And we have something that comes in here with an account that is paying an interest rate of X%, compounded monthly. So divided by 12, and our N is times 12 equals, and it's after 4 years. He has a total of 9,000 Rand and 96 and 92 cents. Okay, now I did actually make this pretty, so I'm just going to erase this quickly. So I just wanted to do it step by step with you to see the logic of it. Sorry, this is not like Zoom where you just erase and, you know, not quite the same. Cool. All right, you'll have to forgive the little dotties if they get in the way. I'm not going to be too pedantic about it. Okay. Okay, so here we can see. Here we can see what I've actually done, but I've done it neatly for you, so you don't have to stress about my handwriting. And then I filled in what's missing. So here we have the initial p-value, and we're looking for A. Then we need to find our initial p-value, which we can get from finding A and subtracting 3,000 Rand. Okay, from that, we can find our next A over here, right? Which is the same as this A over here. And from this, it becomes a P, and then we are just looking for our X percentage. So you can see how it follows along. Now, this worksheet is actually from our grade 11 sets of worksheets. So, yeah, cool. Anyone? Any questions? Let me go back and check if there are any questions here. Questions? Mlingisi, yes, the presentation has started. Are you guys okay? It might be a connectivity issue on your side, but hopefully you can still hear us because I'm on the screen right now. Okay, cool. So I'm going to go back to algebra then, and we'll walk through these things. So what's really, you can actually teach the exponent rules on your calculator, okay? So we have 2 to the power of 3 times 2 to the power of 4 gives us 128, right? And then there are 2 ways to prove this, all right? So we can add so we're doing the product rule of exponents here, okay? So we can add the 2 together. In fact, you know what? It will just be better if I do it on my calculator. So, let me just pull my calculator up. There we go. Okay, so, and let's talk through this exponent rule because it's a really nice exercise. What I did do with the students, I created investigations for grade 8 to 9 doing this sort of thing on the calculator. So it's a lot of fun. Okay, so the first thing is when we have the same basis and we multiply, we know that we add our exponents together. All right, so that's that one. Now, we can do second function and p fact, and that shows us 7. And if we did this, 2 to the power of 3 plus 4 is equal to, we'd get the same answer, right? So we can see that when we are multiplying with the same basis, we can add our exponents together. That's basically what the rule is. So it's a really nice rule and a really nice way to teach it on the calculator. So if you're looking for an investigation, then this is a lot of fun to do with them as well. And again, you can prove the Surds rule in exactly the same way. So when we have Surds where our root is exactly the same, then we can multiply the inside of the Surds together. Okay. Now, there was some confusion about logs. So this is just a step-by-step way on how to do logs with your calculator. And I'm going to actually work through them because there's some really nice log rules here that I want to show you on the calculator. So again, in the same vein of proving the exponent rules, we can prove the log rules as well. So you can see when I have logs with the same base and I'm adding them together, I can multiply my arguments together, right? I had to go and Google what the name of that thingy was yesterday when I was putting this together. So your arguments. So you can go, you can multiply your arguments together. You'll get the same answer. So it's just a quick way to show the rule. Okay. When you subtract logs with the same bases, you can divide your arguments. Okay. So obviously your first argument is divided by your second. All right. Then you have the same with power rule. So if you have an exponent, if you have an argument to the power of an exponent, you can bring that exponent to the front without changing the answer or the value of the log. And of course, your change of base rule, which is very, very handy to have. And so if we have log base 5 and we want to change it to log base 2 or log base 10 or whatever makes you happy, the rule is you put the arguments on top with the new base divided by the new base, and the argument now becomes the old base. And then just a quick reference guide here. Remember that anything to the power of 0 is 1 because log base answer equals exponent. Okay, so if I have the answer of A and it's my base is an A, I know that my exponent is 1. Cool. Then what I've done is I've linked these for you. So this is a study guide chapter on logs. It's from the NCS curriculum. So it will help you cover all of the log rules and logs that you might need for technical maths. And then, of course, there is a worksheet on log functions, and this is an NCS worksheet on log rules as well. So you can go and work through those as well. Then the next thing in algebra is factorization. Okay, so there's two that I want to show you. The first is the highest common factor, and the second is trinomials. So what I want to do is just show you on your calculator. Again. Oh dear. There it is. Okay. Okay. So the highest common factor on your calculator. Okay, and that's not any algebraic values, just your numeric values. So if, for example, you want to find the highest common factor of 85 and 100 randomly, you would say 85, then second function and 2 for GCD, which stands for greatest common divisor, means exactly the same thing, and 100 and equals, and we get 5. Okay, so the highest common factor of 85 and 100 is 5. And of course, we can add as many numbers as we want to the string. Here we go, 105, and we still get a highest common factor of 5. As a side note, which I didn't include in the presentation, but it's really good to know, you also have your lowest common multiple. So if I have 85 and 100, and I want the lowest common multiple of that, I can say equals, and that will give me 1,700. So just for LCM, this is really helpful if you are looking at algebraic fractions with your students. It will help you to find your lowest common denominator. Okay, cool. Then the second thing that I want to show you is table mode. I want to show you how to find factor pairs of any number, and we're going to use that in our techniques for factorizing. Okay. So what I'm going to do is I'm going to say, let's say I want the factor pairs of 36. Okay, so I'm going to have 36 divided by x, so RCL twice, just like we're making a hyperbola, and equals, equals, equals. Then, of course, anything divided by 0 is undefined, which is where this asymptote comes from. Okay, and here's all my factor pairs: 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So I know that 5 is not a factor because it has a decimal remainder, 6 and 6. And then, of course, we've gone back to 7 and 5. So I know that I've got all my factor pairs and I am done. Okay. I see there is a question. So let me just look here. Oh, okay, great. Fantastic. So let's go back to our factorizing. And with trinomials with 1. Okay. So there's the steps for finding your factor pairs, and then let's talk through this here. Okay, so When we look at trinomials where a is 1, because that's always where we're going to start teaching it, right? We always look at the sign at the back. So if my sign at the back is plus, I know that the signs in my brackets are the same, and I take the sign Q to put into my brackets from the thing in front of my B. Okay. If the sign in the front at the back is a negative, then the signs in my brackets are different, and I'll have a plus and a minus. And I'll speak to those examples in a few minutes. Okay. So the first step that we need to do is look at the sign at the back, and we see it's a plus for our first example. So I'm going to write down my brackets, and I can see the sign at the back is a plus, so I have the same signs, and they are both going to be pluses, which is in front of my B. Okay, then what I do is I find all the factor pairs of 8. Now, I would do this on the calculator, but switching has become a bit of a pain, so I'm just going to write them down here. Luckily, 8 is not too complicated. So it's 1 and 8, 2 and 4, 4 and 2, and 8 and 1. Okay, so what we do is, because the sign at the back is a plus, I need to add my two columns together to find my middle term here. So 1 plus 8 gives me 9, not what I'm looking for, so I ignore it. 2 plus 4 gives me 6. That is what I'm looking for, and I can just put it straight into my brackets. Here's my second example. Same signs, because my sign at the back is a plus, and the signs are now going to be minuses. So I'm just going to fill in my x's, and then we're going to use the same technique. So because the sign at the back is a plus, I'm going to add my two columns together. So 1 plus 8 gives me 9. So that was quick and easy. So I'm just going to fill in a 1 and an 8, and I'm done. Now I'm doing particularly easy examples, but what's really great about this methodology is that it works for any size factor. Okay. Then the last one, your sign at the back is a minus. So I'm going to rewrite these. So I've got 1 and 8, 2 and 4, 4 and 2, and 8 and 1. And what I do is I make my one column a minus and my one column a plus. And these are going to be the signs in my brackets. Okay, so all I'm going to do, what happened to my mouse? Oh, there it is. Okay, all I'm going to do is write down my brackets with my x's inside and nothing else. Okay, right, so I have minus 1 plus 8 gives me plus 7, not what I'm looking for. Minus 2 plus 4 gives me plus 2, not what I'm looking for. Minus 4 plus 2 gives me minus 2. That is what I'm looking for. So I can say minus 4 and plus 2, and I'm done. Okay. So yes, these examples were easier. I'm going to erase everything, so I hope you weren't writing anything down. So here's another example, a little bit more complicated. So here are your factor pairs, 1 and 20, 2 and 10, 4 and 5, 5 and 4. The sign at the back is a plus, so it means my signs in the brackets are the same, and I'm going to have two plus signs. So I'm adding the two things together to get my middle term. 1 and 20 doesn't make 9. 2 and 10 doesn't make 9. 4 and 5, yes, that makes 9. So I just write it down, and there we go. Okay, so it's a really nice method for teaching trinomial factorization. I mean, when I was doing extra maths, the one thing that they really struggled with was finding factor pairs of a number. Okay, so this one here, the sign at the back is a minus. So again, I looked for my factor pairs. I've got 1 and 18, 2 and 9, 3 and 6. 4 is not a factor, so let's just cross that out. 5 is not a factor, so I've got 6 and 3, which is the same as that one. So because my sign at the back is a minus, my one column is going to be a minus, and my other is going to be a plus. And we all know that the signs in the brackets are different. So we've got x, and we're adding them or subtracting them, putting them together to make plus 3. So minus 1 plus 18 makes 17, not what I'm looking for. Minus 2 plus 9 gives me plus 7, not what I'm looking for. Minus 3 plus 6 gives me plus 3. Okay, so that is what I'm looking for. So I've got minus 3 and plus 6, and I'm all done. So you can see it's a really nice, easy method just from using your factor pairs on your calculator. So I did actually do an entire factorization workshop. If you would like to go more into depth with it and look at more of the examples, you can click on the YouTube link here after I've shared this presentation with you. Okay, so there are several different methods, and what I'm going to do with you today is the grouping method and the box method. But in the workshop on factorization, I actually cover all four of them with you. Okay, so what I really liked about the Khan Academy method is that it uses grouping. Okay, so the first thing with all of these methods is that you need to multiply the A and the C value together. Okay, so we look for A and C values. So A times or 3 times 70 is 210. So here's my factors over here. Okay, and we're looking for something that adds up to 31. So the sign at the back is a plus, so they add up to 31. So I'm just going to look quickly. Here it is, 10 and 21, right? So what we do is we just split this into minus 10x and minus 21x plus 70. And then we use grouping. So I'm going to group the first two together and the second two together, just because I can. So for the first two, I'm just going to take out an x, and I'm going to be left with 3x minus 10. And with the second one, I'm going to take out a 7. In fact, I'm going to take out a minus 7. Just because I know. Okay, so minus 21 divided by minus 7 is 3x, and plus 70 divided by minus 7 is minus 10. And now you can see your brackets are the same here. So we can write the brackets down, 3x minus 10 and x minus 7, and we are all done. Okay, so that's a really nice method for students who don't like the other methodology. And this is particularly nice when you have those A values that are not 1. Now, the other method that I really liked, and I'm going to show you now, is the box method. Okay, so this method comes from Purple Maths. That is a link that you can follow to see what they do. So again, they firstly, we need to take out a common factor of 3, I think it is. So we're going to take out 3, and we're going to be left with 2x squared. I've taken out a minus as well because it will make it less complicated. So a minus 5x, and this will be minus 12, right? Okay. Then what we do again is you multiply the A and the C value together, and you look for terms that add up to 5. Okay. So we've got 1 and 24, 2 and 12 doesn't make, we've got to subtract. So 3 and 8, right? That's what's going to get us to minus 5. So, sorry, let's just do our signs. So it's going to be plus 3 and minus 8. Okay. Then what we do is we draw a box. Okay. And we split the box into 4. The first quadrant of the box is just going to be this value here, your 2x squared. Okay. Then what we do is we say, okay, I've got plus 3x. So I'm going to put that here. And I've got minus 8x. And these go in these two corners here. Okay. And then, of course, my C value, which is minus 12. Then what you do is you take out common factors across your table. So for these two in this column, your common factor, this is an 8 just by the way, is 2 and 8 is x. So it's going to be 2x, right? And here your common factor is 3. So we'll just call it plus 3. Here, the only common factor is an x. And here your common factor is a minus 4. Okay, so now we've got our brackets. So don't forget the highest common factor that you pulled out first. So we just write that down. And then here are our factors. So it's going to be 2x plus 3 and x minus 4. And that's it. So it's a really nice method. I like the box method. Again, it's particularly for students who struggle with the crossover method, which is the one that I learned in high school, or the actual cross method. So this is, again, a really nice out-of-the-box method, which is, I think, if I'd known about it, I might have used it myself when I was in high school. So, cool. Now, of course, you can also solve for x using your calculator. Okay, so what I'm going to do is actually go back to, I'm going to actually do it on the calculator for you. Okay, you know what? This will just be a lot. Here's my calculator, okay? And what we're going to do is, in table mode, we're going to type in that function. So it was 6x squared plus 15x.
Tell it's Sally. Just let you know you're sharing. I don't think you're sharing the right screen.
Can you not see my calculator?
No, we're seeing your the tech teacher screen. No worries.
Wow. Sorry, guys. Thanks, Sally.
Sure, no worries.
Here, there it is, right? So, and then plus 36. Yeah. So, sorry, let me just go back here. So, we're in table mode. I'm just going to put in the function for you, x squared plus 15x plus 36. So, you can see table mode is really super handy. Again, we're going to skip function 2. Now, let's just go through these. So, with the function, what we're actually looking for is where x is equal to, where the total equation is equal to, or the expression is equal to 0. That's the whole point of factorizing, right? So, we're going to go through our table and look for the points where x is equal to 0. And you can see that's at 4. Now, we know this is a parabola. So you can see that this parabola is just decreasing. So we're not going to get anything that side. So we're going to go look on the other side. Here, we can see we've crossed over from a positive to a negative, between -1 and a -2. So what we actually need to do is, in our step side of things, we're going to divide our 1 by 6, okay? And then if we go look for between -1 and -2, we should find our 0, which is at -1.5. So when we look at how we factorized it earlier, you'll see that it will give us exactly the same answer as that one there. Okay, so again, really nice and easy to do on your calculator. Awesome. Any questions? We're still all happy and wonderful and good before I move on? So the next thing that I want to show you, and I'm going to, forgive me, I'm going to hop back to my calculator again. Oh dear. Hey guys. Sometimes technology is just so much fun. Okay, here we go. So I'm going to go home now, back to normal. So your home button will just take you to normal mode from whichever mode you're in. It's a really nice shortcut instead of having to say mode normal. Okay, so when you do a quadratic equation, we talk about your A, B, and C values, okay, and substituting them in. Now, when we do it in technical maths, we also have the complex numbers in grade 12, but I'll just start with a regular example and then we can go from there. Okay, so let's say our A value is 3. So what we're going to do is store our 3 value into A. Okay, then let's say our B value is -8. So we're going to store that into B, and our C value we'll store that into C. Let's hope this works. Okay. So when you're done with that, what you're going to do is just type in your quadratic formula exactly like how it is. So in other words, we have, -b plus or minus. So I'm just going to put in a plus first, square root. Then we'll have alpha b squared minus 4 alpha a alpha c, right? All over 2a. Okay, so that's that one there, Right. Then we're going to say equals, and it didn't like it. So let me just change my C value to a negative 12. Okay, and I'm going to just type it in again because I lost it when I negative B plus square root, square root of B squared minus 4 alpha A alpha C all over 2A. Okay, so that's our quadratic formula, equals, and it gives us this surd. Okay, and of course you can change it to give you your full X is equal to. Now, for your second one, you don't want to have to do what I just did and retype it in 6 times. So what you do is you just press your left arrow key, and that will take you to the back of your expression that you've just typed in, and you can now edit it. Then to get to the front really quickly, we're going to say second function and left arrow key, and then we just click through to where we want to be. Now you need to be behind. So in other words, this arrow needs to be pointing at the thing that you want to change. So we're going to press backspace to delete it, put in a minus instead, and say equals. And there we go. There's our second answer as well. Okay. So I want to go back to, oh dear, I'm really doing well here. Sorry, guys. I'm brain farting all over the place. Okay, so here it is. Great. Okay, so that's these steps. Is that you can actually go back and change the values of your A, B, and C values. So if you have a couple of these questions, all you would need to do is restore over your B, A, and C values, and then just go back and press equals on this equation, and then it will just give you the new answer, which is really lacquer. So from here, we can move on to cubic equations. So there are a couple of ways to do this. So there's the factor and remainder theorem, where we can use the K method. So I don't think I need to go through this with you, but I do want to show you, again, you can also use your table mode. Let me just do that with you because it's really nice. And then I'll move into the other version of it. So you can use your table mode. Solve the quadratic equation, we can do the same thing with the cubic equation. So I'm just going to use that same example that was there. Minus 15, right? I think that's right. And then we'll go look for our zeros. So this is a nice way to find any factor and then to do the long step method where we use the K method. And what's really great here is you can see exactly in which direction your graph is going. There's your second zero and there's your third zero. So I did get the question right. Now, the really nice thing about the W506 is it actually has an equation solving mode on it. So we can just choose mode and then 4 for equation and then choose 3 for cubic. And then all we would do is fill in the values for A, B, C, and D. So it's going to be 1 equals, 7 equals, 7 equals, and negative 15. And equals, and that will give us exactly what we found when we did it through the table mode as well. Oh. Any questions so far? We're all still awake and alive and here. Okay, fantastic, great. Awesome. Steps for you to follow along with the equation solver. Now, Cynthia was telling me that nature of the roots is quite a struggle for a lot of the students. It was one of the things that they did most poorly in. And I totally understand where they come from because for me, I didn't understand it either until I started teaching extra maths. So what I wanted to talk through and what really helped me with it is the fact that your delta actually comes from your quadratic equation formula that we just spoke about now. You can see it's b squared minus 4ac. Okay. So we need to think of that delta within the square root, okay? So when your delta value, in other words, when this is 0, it means that nothing is being added to that b. So there's only going to be one real answer, right? When your delta is positive, okay, then you can have 0. Okay, so then you can have two unequal roots. So when your delta is a perfect square, then you would have, in other words, when this works out to a perfect square, this value here, then your roots are rational roots. Okay, when it's not a perfect square, then you have irrational roots. Okay, and when this value is negative, you can, well, before you work with complex numbers, you cannot have a negative square root. So that becomes imaginary or non-real. So that's where those those things come from. So I found this really great diagram from Siavula, and I've actually linked it to the explanation of nature of roots as well. So if you click on the picture when you get this presentation, it will take you directly through to the roots. Okay, so then what I wanted to do is just talk through some questions. So these actually come from our grade 11 worksheet on algebra, which includes some questions on nature of roots. Okay, so our A is 5, our B is -3, and our C is 43. Okay, and all we're doing is we're substituting in these values into our delta, or that inner part of the quadratic formula. Okay, so we substitute it in and we get a value of -851. So if we go back to our table, our delta is less than 0, it's negative, which means that our roots are imaginary or complex. With the next example, yes, sorry. So it's still a 5x squared minus 43 is our B, and our C value is 24. And when we put it in, we get a positive value of 1,369. So here, what I immediately did is I square rooted it. Now, if I get a rational number, my roots are real and rational. If my answer gave me 37, blah, 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 then I know that my roots are real, but irrational. So that's, you should always have that check where you do the square roots. And I think that's something that we don't teach as teachers because we just sort of know it. So if you're going to teach them in a stepwise way, then get them to always do the square root straight afterwards and check whether it gives them a perfect square or not. Okay. All right, fantastic. We're on calculus. I hope you're still awake and I haven't put you to sleep yet. Okay, so I actually want to come back to the calculator. So I'm going to go here. And this is still me. Great. I don't see any other questions, so that's awesome. This calculator loves me. There we go. Okay, so the calculator is not here to solve algebra for you. It's here to help you find the value of a number. So yes, while we can do integration at a point, or sorry, differentiation at points and integration between 2 points, it will never ever be able to give you an algebraic answer. Okay. And that's purely because it doesn't use the methodology of the rules. It uses the Newton estimation process. Okay, so you'll see sometimes when you put it in, you get 0.000001, which is the size of your error. And that's just because it doesn't use the same rules as we use in mathematical theory terms to get to the same points. Okay, your answer will still be right. Take it from one who's done applied maths and use those methods, but it's just the calculator is going a different route to the route that we would take. Okay, so it's purely a checking mechanism is what I'm trying to get to. Okay, now that we're there, so what you can do is you can put in any x sort of expression. Okay, and then we want to differentiate this at the point where x is equal to 1, for example, and equals, and there you go. So you can see exactly what I'm talking about here because it's using an estimation process. So actually the answer is 14, but because of that estimation process, it's got that tail of 1, which we would exclude anyway when we're talking about this. Okay, so let me just repeat that for you. So to get your differential, you press alpha and your close bracket button, and it gives you this dx. And then again, you just type in whatever you want to on your calculator at the value of x. So when x is equal to -1, for example, and equals. And again, you can see what I'm talking about here. So the answer is 8. Okay. Now, you can also do integration between 2 points. So we can say alpha and open brackets. And we can say between the point of 1 and 2. So you just use your arrow keys to go through the integral. And let's say we have x squared plus 3x, right? And equals, and you'll see it says busy. So the more complex your integral is, obviously, the longer it's going to take to solve it. So if, for example, we did an integral between 0 and 1 for sine x, okay, is equal to, you'll see it will take a lot longer because it's now doing a longer calculation. And that is the area of the curve between 0 and when x is 0 and x is 1 for sine x. Okay. Cool. So that's pretty much what calculus is. So it's so weird to like jump between my face and then, you know. So what I want to show you now, and I'll do it all on the calculator. I just want to work through what I need to show you next. Okay, great. So guys, you're gonna love my face. It's gonna be wonderful. Okay, I should put a bit. We are now on the calculator, right? Okay, so the first thing that I want to show you is converting units, which is really, really great. Okay, so let's say, for example, you have 24 ounces and you want to know how many grams that is. So you put on your calculator 24, then you use your alpha button, and over here you've got this blue that says convert. So we're just going to press 5 for convert, and then all you're going to do is go through your calculator and look for the point where it says pounds to grams. Okay, so we're just going to look through, not there, ounces to grams. Oh, there you go, ounces to grams. That's what we're looking for. So our conversion number is 13, and then we just say equals. So 24 ounces is 680 grams. Okay, so that's conversions. You have, I think there's 44 of them. Let's just check again. So you can just scroll through. We don't use, probably from after this one where we talk about gallons and meters, there's all sorts of other fun ones to use. So we wouldn't probably use the first batch. So you've got 44 different options. What's also really nice is you have a constant. So when we're talking about technical science here, you've got all of these constants on the calculator for you. So if you're looking for them, what you can do is just say, for example, I want the constant of alpha. Now, listen, I don't speak science, so I don't know what alpha means in science land. So it would just actually, it actually has that value of alpha saved into the calculator for you so that you don't have to type this long value into the calculator, basically. It's just a time-saving mechanism. And I think you have 52 of them. So you really have a lot available to you to use. Okay. Then the next thing that I want to show you is how to convert between degrees and radians. So your calculator is automatically set on degrees. That's that one over there. Okay. And let's say we have 30 degrees and we want to convert them into radians. Okay. So what we would do is there's the long method, which I'm going to show you first. There's the short method, and then there's the really epic, awesome short method. So we'll start with the long method. So you'll see we said second function setup, and your very first option is 0 for degrees, radians, and gradients. So you would just choose 0, and then we want radians, so we say 1. And sorry, I should have pressed equals first. So let's just go back here and I'll do it again. Okay, so we've got 30 degrees, right? And then we say setup and radians, and it still doesn't love me. So that's not going to work. So that's why it's a horrible method. So what we actually do is we say second function and this one here, and then it will convert it for us into degrees. Now, what have I done? So let's say we have 30 degrees. Then we say second function and DRG, and there's my radians there for you. You can change that to suit you. And then again, we can say second function DRG, and that will give us gradients, and then back to degrees. So let me show you the really awesome shortcut version. So what we do is we store into our shortcut key our functions, second function, and decimal to give DRG. Now, these keys here, D1, D2, D3, are just really awesome shortcut keys. They just save a shortcut version of a key sequence that's already available. So you cannot store a formula or anything like that, not allowed. But it's just really handy if you're going to work with the random function on the calculator or something along those lines, or you want to save X into there, or whatever, or the conversions, conversion setting, anything you like. So now, if I have 50 degrees and I want to know how many radians, I just press D1, and then it will calculate that for me as well. Then, of course, if I have a quarter radian, like so, like so, and then I want to go back to degrees, I can just click that button twice, and it will take me to degrees. So this is just a really nice quick shortcut. I recommend saving it to your calculator, particularly if you're going to do a lot of work with radians and degrees. There was a lot of talk yesterday about making technical maths applicable to the other topics that students are doing. So being able to quickly find the radians instead of having to do the long mathematical formula for it really does help quite a lot as well. Now, from that, we can actually talk about time calculations, which I just want to show you very quickly. Okay, so there's 3 different ways we can do this. Let's do the speed distance time calculation. Okay, so for example, if I'm traveling to Durban, which is 700 kilometers away, and I drive an average speed of 115 kilometers per hour. Okay, how long does it take me to get there? So it's going to be 6 hours, maybe 10 minutes, maybe 5 minutes, I'm not sure. So what I do is I say second function and DMS, and it gives me 6 hours, 5 minutes, and 13 seconds. Okay, obviously that doesn't include any breaks you might take, but so that's the first option. Your second option is the Susie train station question. So Susie gets on the train at 9:45. She gets off at 12:30. How long was she on the train for? Okay, so she gets off at 12:30, so we always put the later time first. So you're going to say hours, then you press the DMS button, then your minutes. Okay, just like you would write in the time. Okay, minus hours, DMS button, minutes. Now you don't have to put the DMS button again. If you want to include seconds, then you would press DMS again and then type in your seconds and just equals, and it gives us 2 hours and 45 minutes that Susie was on the train. Now what you can do is again press second function and DMS, and it gives you 2 3/4 of an hour. So if we change that, 2,75 hours. Okay, so obviously that is a really nice way to do that question with your students. And what's nice is it's on both the 535 and the 506 as well. Okay, then the last type of question is your how many minutes in an hour question. Okay, so if, for example, I have 470 minutes and I want to know how many hours that is, what I would do is put a 0 in my hours placeholder, press my DMS button, type in 470, and then equals. And then I get 7 hours and 50 minutes, and I can then change it again, and 7 5/6 of an hour, or 7,83333, and so on. Okay, for those who missed it, that is a recurring function exclusively to Sharp that you can turn on with your calculator, which is really nice for showing your students the recurring values as well. Okay, so those were those steps. What I want to show you now is, I think we're almost done. I hope you're still awake. Okay. trigonometry. Okay, so we did discuss graphs earlier, so I'm not going to repeat it because it's very similar in theory to what we were doing. Okay, so what we do is in table mode, we type in the sine graph. And then, of course, obviously, you're not going to make your start 0. You can make it negative 180. And then your step, we would make, say, 15 instead of 1 because, you know, 1 will take you a very long time to draw the graph, right? And then, of course, here are all of your coordinate pairs. So you can just scroll through your table and look at them. Okay. Now, before we draw the graph, this is GeoGebra, and I just wanted to mention it. So GeoGebra's got this GeoGebra classroom thing, which is very, very cool. So you can actually create an activity on GeoGebra or use an activity from GeoGebra. You can then create a class and then share it with your students. So you just enter, you give them a code or send it to the email address. I haven't actually tried it myself. I'm not going to lie to you. And then they can actually do the activity themselves and you can just watch them doing it, which is awesome. Okay, so this whole picture is linked. So when you get the presentation, if you click on the picture, it will take you through to GeoGebra. Then, of course, GeoGebra also has some really wonderful resources and activities for you to do on GeoGebra. So again, this is linked to this page with the various activities. And I think for technical maths, I mean, you want to look at the calculus activities and look at graphing those graphs and look at the integrals and the differential graphs and how they interact with each other as well. Okay, so drawing a trig graph is not exactly the most fun on GeoGebra. Forgive me, people from GeoGebra. I love you. So you need to actually go and change the settings on your x-axis. So these are the steps to do that, and it will really help you. So when I do question papers, those free worksheets that you guys download, I actually use the dots and I draw the graph in with the word function. So I have not advanced that much technologically speaking. But also, please, guys, when you're doing trig graphs, please do not use a semicolon, okay, because it will change the way that your points are plotted. You must always use a comma, okay? Just as a side note, it gives me gray hairs every time I do it. But, you know, okay. So we did the first sine graph, and then we can look at the effect of A on sine, right? So it's exactly the same steps. So here's my original sine graph here. Let me draw for you. Okay, it doesn't want to let me draw. So here's my original sine graph, and here's it being multiplied by 2. So you can see that the graph has actually just been pulled upwards towards 2 or stretched. Oh dear, it's just stop sharing and try again because it's being funny. Yay! Okay. You know what it is? I think this presentation is so big that it's actually frozen. Sorry, guys. Oh dear. Okay. What I did want to show you, I'm not sure. Sorry, I'm just going to try and fight with it a little bit and see if I can get it for you. Okay. What did I just do? Sorry. Okay. I'm actually just going to do it. Apologies for my technical goofing. I'm actually just going to do it from here. Sorry that you can't see. Well, it'll be smaller, but hopefully you can still sort of see. So these are the coordinates, right? Then you can see my PowerPoint is just far too large. So then we looked at the effect of when A is a half, and you can see it's actually shrunk down over there, which is quite nice. So it's a really nice visual way of showing your learners what is going on. Then again, if we shift the graph, so we add 1, you can see that shift quite nicely. So there's your original graph, and of course, here is your shifted graph. And you can see they've all been shifted up 1 unit, which is really great. Let's skip that one. What I do want to share with you is this. So let's try this again. And let me just see what I am sharing with you. Is it? Sorry. Let's try this. Okay, cool. So solving trig equations, because it's really, really awesome. And there we go. So here's my first example. I'm going to run through it very quickly. I want to actually look at the specific solution with you. I'm going to try and aim to be finished before 3 o'clock. Okay. So here's my first example, and I took this out of our grade 11 trigonometry worksheet, which should be pretty the same standard for maths as it is for technical maths. Okay, so what we do is our first step is obviously to get rid of the thing in front of the sign or attached to the sign, but that's not part of the angle. So we're going to take this 3 to the other side. So we're going to have 1 divided by 3. Now, this is one whole angle. So the next step is to look for the inverse or the arc sign. So it's going to be sine of a third, and that's going to give us a reference angle of 19.47. Okay, so x plus 30 is equal to 19.47. Okay, now sine, remember our cast diagram, right? Our cast diagram said we had all are positive, sine is positive. So what's going to happen is in the first one, we're going to have our 19 degrees, and then, of course, we bring 30 across plus K360. Then from our second quadrant, we have 180 minus 19 degrees minus our 30, which we brought across, plus K360. And this gives us 2 general solutions, okay? Because if we think about the graph, if we drew a line through it, it would hit that graph twice in a certain period, in a 360-degree period, okay? So for our specific solution, what I want to do is I'm going to start and I'm going to share my calculator with you instead. There we go. Okay, so specific solution into our table mode. Now, just trust me. I mean, I love table mode, and you can see that. So the first one we had was negative 10, I think 0.57. Just please forgive me for inaccuracy here. Plus, and then it was K360. So we obviously can't put it in K, so we're going to put in an X instead, times 360. Right. Then for function 2, it was 130.37, okay, plus K360, so X times 360, right? Then we were looking for solutions between, I think it was negative 210 and 180. Let's just make it that, okay? So what we do is we look for answers between negative 210. So that's too low, that's too low. Then the next one, that's right. So that's our first specific solution, and there's our second specific solution, and then these are bigger than 180, so they are all done, and we found all of our solutions very quickly. Hi, Sakio. Okay, awesome. Thanks for joining us. So what I'm going to do now is I'm going to go back to the presentation. I think we're almost done here. So just hold on for me for a couple. We are done. How's that for timing? Okay, so yes, for those of you who have joined our session today, I am going to send you a calculator, the one that we've worked on today for technical maths. It's really, really nice, so you can go and play with it. There are technical maths 506 workshops on our YouTube channel as well. And then if you really like it, they can be ordered in bulk directly from us at SMD. Our special pricing for schools at the moment is 300 Rand a calculator. So they're really cheap. If you go into a store, you're not going to find them cheaper than 500 Rand a calculator. Okay. And then, of course, Take-A-Lot, P&A, Loot, Macro, have them if you do not want to order them directly. Okay, then the W535SA, yes, it is cheaper. It's got less functions. So it doesn't have the equation solver or the conversion solver or the complex mode. Okay, so if you are struggling with your students at least give them some of the functions, because the main one, which is a table function, is very, very helpful. And you'll be able to do a lot of the stuff that we did today just with this calculator. So it's, yeah, it loses a couple of things, but I mean, for the most part, you'll still be able to do a lot better with your students. So these are 200 Rand a calculator each. Okay, so guys, thank you so, so much for your time. Please remember to visit maths@sharp.co.za. There are free worksheets. I have started technical maths worksheets, but they're not as prolific as the other maths topics. But yes, if you need anything and you're struggling, I am happy to put it on my list to create. So give me at least 2 or 3 weeks notice to create something for you as well. Okay. Cool. And then, of course, you can download all of the simulators from Maths@Sharp as well. So just look out for them there. Fantastic. So, guys, are there any questions, any thoughts? How are you feeling? Have you all fallen asleep? I see there's one Q&A. Awesome. Patty sees, where is it possible to do the rules inductively, probably using functions? I'm not sure which you are referring to, but yeah, if you're talking about rules with differentiation and teaching it, I'm sure there's a way to do it. I've just never thought about doing it that way. I must be honest with you. So just yeah. Oh, hello, Relay. I'm so glad that you joined us again. It's nice to have you here. Ah, hello, Edward. Awesome. How are you guys? It's so nice to see that you're part of the Sasol TechnoX thing. Okay, awesome. Any other questions? We're all happy and good. Guys, can I just, as a quick thing, would you mind popping your email addresses into the chat function so that I can grab them quickly? Or otherwise, what you can do is send me a message on my account with your email address, just so that I know who was here. Then I'll be able to contact you tomorrow and set up your delivery of your calculator quickly, instead of doing it later or slower. So if you want to speed up the process, then either send me your email address now. Oh, awesome. Thank you, Sikiwo. And then I will send it to you in in a couple of days. Let me just start a new page here. Awesome. Fantastic. Thank you, everybody. This is really great. I'm actually just going to do that. Thanks, Akiwa. I appreciate that. That's lovely feedback. Cool. Fantastic. Awesome. How have you guys found the conference? Has it been good? Positive? TUT. Oh, how exciting. Are you studying at TUT or are you a lecturer? I'm going to butcher this. Sorry. Mungamele, can you please give me your email address as well? Yes, only everybody who attended will get a calculator. So yeah, I will follow up again. Please just send me your email addresses now for those who are here right now, and then I will follow up with Cynthia in case I've missed anybody who might have had to leave early. But yes, everyone will be receiving a calculator for today. You know, because when we did this in person, we would give you calculators at the beginning and you could actually follow along with the live session. So it's a little bit more difficult. But, you know, hopefully when once you get it, you'll play with it. And then if you do have questions, you'll have my email address. So you're welcome to send me any questions that you might have or anything that you're struggling with. If there are any facilitators here who've joined us, please let me know. I'm happy to do a workshop, not maybe as long as this one, with your teachers. So you can just let me know if you've got any questions. Patisizwe, I like to use tables. Absolutely, absolutely. Yes, you can definitely use them to teach exponents and log rules without question. I do, actually, I'm going to share it here. I've got an investigation for grade 9, which I think you will like. So I'm going to just share it here with you quickly. Which does the teaching of the exponents. There you go. Did that work? There we go. Okay, so you're welcome to use that investigation. It's really, really nice. Let me give you the memo as well. Awesome. Okay, so Ndlelehle, you're a lecturer for basic skills for maths. Oh, awesome. That is so, so great. We've got some lovely basic grade 8 to 9 maths worksheets, and the mathsjourney.com also has some lovely stuff. So if you need any resources, please let me know. Oh, Shames, thanks. I'm gonna go see Lely. Thank you so much. I appreciate that feedback. It's really nice to hear. Yeah, we do. We really need to teach calculator skills more and more, for sure, for sure. And we are going to start working on a SACE registered workshop for teachers, so that when you do workshops like these with us, you will get SACE points. Yay for CPD points. So that is something that is on the horizon. It might be a 6-month one, but it's definitely coming, I promise. So once that's up and running, we will for sure let you guys know about it as well. Would you, if you want, I'm happy to add you guys to our newsletter. If you don't get it already, then you can catch up on other news things. And then hopefully we'll also see you for the AMISA conference that's happening in July 14th to the 16th of July. So that's then. So hopefully we'll see you for that one as well. All right, guys, I don't see any other questions, email addresses, anything else popping up. Everyone good? We've all had a good time. Yeah, I really hope this has been helpful for you, and that the next time we have one, you'll join us again. Awesome. Guys, in that case, Sally, thank you so much for your help today. I really do appreciate it. It's nice to have a backup person. Awesome. All right, guys.
Just let the attendees know that we'll be taking a break now until 3:30. And if you can all make your way back to the main breakaway discussion room, we will be hosting feedback on all the breakaways. So there's a break now until 3:30, and you just need to click on the main breakaway discussion tab to attend the next session and the wrap up of the conference. Thank you, Tal.
Thanks, hey, Sally. Cool. Thanks, guys. Enjoy the rest of your conference. And hopefully we'll see you soon in real life. And please stay safe. Please, please, please. Gauteng is nuts right now. So just take care of yourselves. Okay. Awesome. Cheers, everybody.